Hi everyone, welcome to another episode on Learn All Things Cyber with T. When we started a series on cryptography, I was able to explain a few concepts that surrounds cryptography, cryptanalysis in the first video in the first week of the series. And then today we will be looking more into some of those explanations, and we would wrap up the series on cryptography for the third week. And when we are wrapping it up, we'll be doing things that are related to real life use case. How is cryptography related to cryptocurrency? How is, how we can understand it based on our day-to-day usage, because I know the topic can look a little bit abstract. So, but today, I'd like to explain, in the first week, I explained what cryptography means, the three types of cryptographic algorithm. I explained the hashing function, the symmetric encryption, the asymmetric encryption. I was able to give few explanations, but today I would also start from there and then we'll go further into the series. Basically, like I explained in the first week of the series, I explained that, okay, so we have cryptography, and then we have hashing, we have symmetric encryption, and we have asymmetric encryption. So now I'll give further details. I was able to explain it when we did the first week, but I'll try to explain symmetric and asymmetric properly because it comes out all the time. I'd also explain something that we call digital signature. It's very important in cryptography. These are like the key things you need to know. When you say you have read about cryptography, they expect you to know what symmetric and asymmetric actually mean. So let's quickly look at symmetric. So symmetric encryption. Now, what is symmetric encryption? We usually call it single key kind of encryption. And what does it mean? Now, before I explain what it means, in cryptography, we usually have three characters. So in cybersecurity, when we're explaining stuff, usually use names of people that are, very closely used with the topic. So basically in cryptography, we have three characters. The first one is Alice, the second one is Bob, and the third one is Mallory. So who is Alice? Alice is like the sender. Bob is the receiver, and Mallory is the attacker. So usually when you have these three names in cryptography, you already know what they stand for. So for symmetric encryption, because it is a single key, as I was explaining in the first week. So why symmetric encryption is not the best, is not exactly very secured, is because you only need a single key to encrypt and de-encrypt the file, the information you're trying to pass, the data, whatever it is. So say for example, you have a box that you closed. You needed to send it to your friend. Now, your friend needs the same key. Maybe not exactly the key with you, but maybe you have a duplicate of the same key in order to open the box. Say for example, someone else's have that key with them. They also will be able to open the box and read what is inside. And that's what symmetric encryption means. So for symmetric encryption, Alice is the sender and Bob is the receiver. So Alice needs to find a way to send the key to Bob so that Bob can also have this key. After sending the key to Bob, Alice would then encrypt that information or that file, let's say file, and then send it with a key, with the same key, send the ciphertext to Bob, and then Bob will use the same key to de-encrypt the file. That's basically what symmetric encryption is. For asymmetric encryption. Asymmetric encryption entails a pair of key as opposed to symmetric. Symmetric is always very fast. The speed is there, but asymmetric is a little slower because it entails like a pair of key. So I'd already explained what Alice and Bob, who they are and who Mallory is. So let's say, for example, Alice. Alice wants to send a message to Bob using asymmetric encryption. Remember, I told you asymmetric will require a pair of key. Now, the first thing that happens is that Bob will generate a pair of key. And this key will contain public and private key. So, public/private key. Now, Bob will keep his private key to himself. It's private. I'm supposed to keep what is private. Now, Bob would publish his public key. Because Bob has published his public key, Alice would have it. And because Alice has the public key of Bob, who is the recipient or the receiver, Alice can then send a message to Bob, encrypt the message with Bob's public key. Remember, it's only Bob's public key that Alice have with her. So she'll send the key to Bob, and Bob is the only person with his private key. Bob is the only person that can de-encrypt this message that Alice is sending. Let's say, for example, Mallory. Like we mentioned who Mallory is. Mallory is the attacker, right? Now, let's say Mallory also have Bob's public key. Mallory can also see this message that Alice is sending. Mallory will not be able to de-encrypt it because Mallory does not have Bob's private key. You understand it? So this is how asymmetric work. It takes a pair of key to be able to send a message, encrypt it. The sender encrypts with the public key of the recipient, and the recipient, the authenticated recipient, actually de-encrypts using their private key that has been, generated initially, which was a pair. So it's like the same pair. It's not like a different private key somewhere and a different public key. No, it was generated together. The public one was published, the private one was kept. The sender uses the public one to send a message to Bob. Bob would de-encrypt with his own private key. Mallory would not be able to, even if Mallory have both information, because Mallory does not have the private key of Bob. So that's how asymmetric actually works. So for digital signature, like I said, I was going to explain. Digital signature is a combination of asymmetric encryption plus hashing. So we have digital signature, asymmetric plus hashing. Now, what's the function of digital signature? Why are we not using just asymmetric encryption, right? Digital signature actually helps two things. It helps to authenticate the sender, and it also helps to preserve integrity. Remember, I mentioned that integrity is when the message you're sending is unchanged, is unmodified. Now, this does the authentication, and hashing does the integrity part. If you remember what I explained as authentication, that the identity of the person is actually confirmed. That's what authentication is all about. So when the identity is confirmed, say for example you're using your username and your password, or entering into a system, you have your data on that system, so the system is checking, does this person actually exist on our system? And the system is giving response, yes, they exist on our system, allow them to log in. That's what authentication is about. So digital signature is a combination. Now let's bring it back to using Bob and Alice. So what happens in the case Alice wants to send a message with a digital signature to Bob? So this is Alice and this is Bob. Don't forget, we are referring to asymmetric encryption plus hashing. That's what digital signature is about. So the first thing Alice is doing is to hash a message or a file or whatever it is. She's hashing the message and she's encrypting the message. So encrypting the message with her signature. So she encrypts the message with a signature using a private key. That's what she does. So in the pair that Alice generated, public and private, she would make a signature that the message is actually from me with her own private key. She would have hashed a message or a file or whatever it is. Now she'll send the message to Bob. As she's sending the message to Bob, she's sending it alongside with a public key. You remember that public key, anybody can see public key. It can be published. So she's sending it alongside with her public key. Now when it gets to Bob, Bob will be trying to decrypt this message. Decrypt the message with Alice's public key, right? Now, while Bob is trying to decrypt this message with Alice's public key, Bob would generate a reference hash value. So while they're encrypting this, there will be a reference hash value from the whole decryption. Now, once Bob have this reference hash value, Bob himself will compute an hash outside of this process. Once an hash is computed, Bob would compare this hash that is computed with the hash value that he got from Alice's message, just to be sure that the message is correct and is actually from Alice. Just to explain this part further, so let's say, for example, the message Alice is sending is hello, for example. Now, when Bob de-encrypts with Alice's public key, the reference hash value would be hello. But Bob will not believe this hello yet. Bob would compute the hash for hello. And once Bob could get what the hash is, then we'll compare it with this. And then we'll be able to say that the hash value is the same. I hope you understand this. I'll quickly talk about who certificate authority is, and after then I'll just talk about few terminologies that you might come across with cryptography. And with these few terminologies, we'll wrap up this episode. So, who is certificate authority? They're like a digital notary. So, say for example, you go to a notary public. When you go to a notary public wants to see you while signing the document you are asking them to notarize. That's how it works. So again, certificate authority are also like digital notary. So it's like saying a company or a website is saying, please trust our website because the public key attached to our website belongs to us. It's actually certificate authority that would verify and be sure that they are the owner and they can be trusted. You know, when you go to that lock sign, the lock sign on website, and you click on it and they tell you, you know, certificate is trusted or something like that. That's the work of certificate authority. I just wanted to mention that on the side so that you have an idea. So they check for this public key and be sure that, you know, the owners are actually the owners and can be trusted. Now, I wanted to talk about a few terminologies when it comes to, you know, cryptography, and we'll wrap it up at this end. And some of the terminologies, remember at first I mentioned something around hashing, and I mentioned that we have different types. We have the MD5, we have the SHA-1, which is not used at this moment, and we have the SHA-2, and an example of SHA-2 will be SHA-256 and SHA-512. Now, let's just talk about few terminologies when it comes to cryptography. And I had explained before to you that hashing is just converting a word or a file or whatever it is to a fixed string or length of, you know, different character, words, number, and whatever it is. That's what hash is. So this is hash. Now, hash is a one-way function. You cannot reverse it. Say, for example, I decide to convert something like hello into the hash of hello. I cannot pick this now and then say I want to reverse it back to hello, to hello. So why this is so is because we use hashing in password database. So for some of you that are familiar with password manager like LastPass, they usually store some of the password using hash. Say for example, you have your password as Peter is not the best password, 123 hash, and you want to store it in their database. They don't store it as this, they convert it to hash and have it stored. Now if an attacker gets hold of their database, the attacker will just be seeing gibberish, different numbers, letter combination. They won't be able to exactly see your password, and that's how hash actually works. So yes, that's how hash works. And another terminology I would like to explain is salt or salting. Now, how does salt work? Remember I said something around hello converting into hash, right? Now, salt is just adding a random string to your password. It is very random, like it's generated random string to your password before the hashing. So say for example, I am using a specific password, my friend is using the same password. When salting occurs, these passwords are not saved the same, and this is what I mean. Let's say friend A is using hello and friend B is using hello also. When salting is added, random thing might be added like 2 3 4 8 7 to friend A, 1 2 7 8 9 can be added to friend B, and then before hashing is done. This is another step away from hashing that helps you to secure your data more in the database, or your password more in the database. So if the hashing of both password are done, they won't come out the same, and this is the function of salting. Now the last part of it is peppering or peppering, however way you want to call it. So peppering, I was mentioning that this could be password stored in database. In the case of peppering, the difference is that peppering is not stored in the database. It is hidden somewhere in your code or in your environment. It is not stored where an attacker can easily have access to it. It is another layer of security that people had to password storage and the rest. So I'll try to explain these three concepts in our day-to-day life. Say for example, you're trying to make a pancake. So trying to make a pancake is like the hash is a simple thing. You're making a pancake. Now you try to add salt to that pancake, for example. So if I add salt to my pancake and my friend is also making the same pancake with the same flour, added salt to it, it won't taste the same. It won't exactly taste the same, because however way we are adding salt to it will be different. I might add more salt to it, she might add less salt. It might be 1 ml salt less or something like that, or one whatever salt left less than mine. So because of that, it won't come out the same. It won't taste the same. It might be very close, but it won't taste the same. Now, what is peppering in this context? So peppering is like saying we are using a family recipe, or I am using a secret family recipe to prepare my pancake. My friend is not using the family recipe to prepare the pancake. So even if an attacker have the same quantity of salt that I use, knows the same flour that I use, without the family recipe, they would not be able to do it exactly the same. So if I have all of those and I have the secret family recipe that I'm using, and my friend doesn't have the secret family recipe, that means my friend will not be able to do it according to that recipe. I will be able to do it according to the recipe. So no matter what, even if the attacker have every other information and they cannot really get into wherever it is stored, or because it's not stored on the database, they won't be able to still get what your password means. I hope this helps.